Welcome, everybody. Thank you for joining me in this talk, The Power of Choice in Docker EE 2.0. I am Anoop Kumar. I'm a solutions architect at Docker. I've been with Docker for 3 years now. In the startup world, that's like 300 years, I think. Docker is about 5.5 years, so I'm not sure if I can still call it a startup, but I think I can. Before Docker, I was at an equally amazing and interesting company called Puppet Labs. It's called Puppet now. And prior to that, I was lost in the dark world of government consulting. I don't know how much you know about US government agencies. They're very big, they're very slow, they're completely non-agile. If you say that you love agile methodology, they would just fire you, right? So I'm very happy, I'm very glad to be outside from that world and on this side of the world. I'm very excited to be here. Thank you for having me here. Right. So I have some slides, about a dozen slides. We'll have a Q&A at the end, about 5-10 minutes, whatever. If the demo gods help me, we'll also have a demo. My internet was not working very well, but I hope we can do it if time permits, of course. Before I jump into the slides, I just want to do a quick show of hands. How many of you knew of Docker before you registered to this container conference? Everybody. Okay. That was a trick question. I did not really mean it. Come on. Coming into a container conference and asking whether you knew about Docker? No. Sorry. I have some proper questions. How many of you knew that Docker actually sells products commercially? Okay. Most of you. Not everybody, but most of you. So, yeah, we do sell. And another last question. How many of you know that Kubernetes is supported natively within the Docker platform? Oh, very similar thing. So fantastic, yes. So yes, we do sell products. We actually sell products, services, support. We also had a PaaS solution called Docker Cloud. It came out of Tutum, if you knew about that. We closed that. So we do sell products, and we have two flavors of products. We have what is known as Docker EE, which is Docker Enterprise Edition, which is what I'm going to talk to you about here. And we also have Docker CE, which is the Community Edition. The Community Edition is the free open source version. Anybody can download it from the internet. You can run it. I see many individuals run it, many small organizations run it, many training institutes run it. So that's totally fine. On the Docker Enterprise Edition, this is what we sell. We sell subscriptions. These are annual subscriptions that we sell for enterprises. There are 3 sub-flavors in the Docker Enterprise Edition itself. There is what is known as Basic, Standard, and Advanced. Basic is essentially just the engine part, just the Docker daemon part. It is very similar to the Docker CE, except it has some additional value-add features around security. This is necessary for organizations. If they have security compliance, benchmark testing, and all that, they would want to use the basic Docker EE product. Then you have the standard. The standard is essentially everything that you had in the basic, and there's another stack. There's a stack of 2 other products that comes as part of the standard. The 2 products are what we call as UCP, Universal Control Plane. So this is essentially the graphical interface. This is the management plane. This allows you to see your cluster, look at the health of your cluster, CPU usage, memory, disk. You can see containers running, applications coming up, health. You can add nodes. You can connect it, connect the UCP. You can use RBAC controls by using your corporate directory server, Active Directory, logging systems, all that sort of stuff. So that is the UCP. That is your management or control plane. And then on top of that, we also have another product, which is the Docker Trusted Registry. This is essentially an enterprise registry. This is where you would store your images. You would host your images. So there are many organizations which wants to store images inside their firewall. They do not want to use a cloud-based storage like Hub or whatever. This could be for various reasons. This could be for security reasons, for protecting intellectual property, or for some other reasons, bandwidth usage, saving costs, and whatnot. But that's the entire stack in the standard. The other differentiating aspect is that it supports Windows. So Windows is another thing. Linux containers have been there for a very long time, but Windows is something that we supported in the enterprise editions. And finally, you have the advanced subflavor, which has everything from the basic and the standard, and there are some additional value adds. So this is around multi-tenancy of nodes, node-based RBAC, role-based access control, and also around some security settings like scanning of images, checking for vulnerabilities against a CVE database and triggering out some alerts and all that. Okay? So Docker EE 2.0 specifically is the next gen of Docker EE. This is the one that started with the Kubernetes support, right? So Docker EE 2.0 was released in the beginning of this year, I think February of this year. So we have had this Kubernetes support for approximately 6 months, and this is being used by a lot of our customers. And matter of fact, the reason we did this was because there was a lot of demand, there was a lot of there were many asks from our enterprise customers. They like the Docker EE story, they like the simplicity of Docker EE, they want support, but then they had certain applications, certain use cases which seemed to be a fit for Kubernetes, and they wanted us to incorporate Kubernetes and provide the same kind of features, same kind of intuitiveness, ease of use, simplicity, lightweightedness, and that is why we included Kubernetes. I just want to clarify, this was not a pivot of any sort. It's just that Kubernetes was of demand. Tomorrow, if another XYZ product came into the market and there's a lot of demand, there's sufficient demand, and we can integrate it with our product, yeah, we'll definitely do that. Today happens to be Kubernetes, tomorrow can be something else. If you have been using the older flavors, like Swarm or Swarm Mode, those are still there. We support them, we are actively developing them, we are actively fixing bugs and enhancing them. All right? Okay, so with that level set, I think we can get into the slides. Let me turn this on. So this is a quote by the CIO of Liberty Mutual. This was a quote made at DockerCon 2018, which was just a few months back. I'm not going to read it word for word, and the emphasis is mine. But I just wanted to bring your attention to the underlined text. Essentially, what he is saying is that today the competition is so fierce that it is necessary for organizations to embrace change. And also, we need to be able to react to those changes. We need to be able to reconfigure our priorities in real time. It means very, very quickly, right? Another very similar quote. This is from the Forrester report from their CIO Success Edition from April 2017. This was also saying that change can come from anywhere, and then we need to be flexible, and we need to be able to very quickly address those changes, right? The common thing between both of them is about change and how do we react quickly to both of them. Now the answer would be agile, right? You can be agile, but then you can only be agile as long as your tools and technologies allow you to be agile, right? There are many tools in the market, many popular tools that I know, which shoehorn the organization into doing business in a certain way. And this could be for various reasons. This could be because they cannot provide that freedom of choice, because if they do, they lose the lightweightedness of their platform, or it could also be, excuse me. It could also be that it is a strategy that they actually want to lock you in their way of doing business, right? In the next slides, I'm going to show you how Docker EE addresses these concerns, and actually it also provides many value-add features to organizations around security, governance, end-to-end lifecycle management, automation, and extensibility. Right? It's all about choice today. Right? It's not just about managing containers and orchestrations. It's about doing more for the enterprise, because today's enterprises require all these additional features. So this is the philosophy behind which we built Docker EE. So these are the pillars over which Docker EE stands. This is a sort of a promise that these will be always provided within Docker EE. So we're talking about freedom of choice, which is going to be the focus of this talk. We're talking about security, enterprise security, and also we are talking about operational agility, right? Freedom of choice essentially means that you should be able to run in whatever infrastructure you're running on, whatever operating system. It could be cloud, multi-cloud, hybrid, VM, bare metal, what have you. You should be able to use Windows or Linux. If you happen to be a Windows shop, yes, that should be perfectly fine. Linux, that should not be a problem. It does not matter where you are in the journey. You could be a very old legacy-oriented organization which has many COTS packages. That should not be a problem. Or you could be a greenfield application which is using microservices, IoT, serverless, machine learning, whatever. So it should not really matter, right? Security is essentially what I call as the peace of mind requirement or peace of mind objective. This is very necessary for organizations to ensure that their data is safe, they're running applications in a safe way, they have governance controls, they have audit logs for everything that is happening in their environment. They have a chain of custody, which is essentially they know who has access to what components in their cluster. And also they have a pathway of mitigating threat through vulnerability checking and whatnot. Operational agility is essentially standardizing your processes in order to drive efficiency so that you have faster releases, faster bug fixes, faster development, faster testing. And this efficiency is realized as cost savings for the organizations. So we, in Docker EE, or Docker EE is probably the only platform which is still lightweight and still balances all three of them. So I call this as the and slide. It's not or. You get freedom of choice and security and agility, all three of them. Okay, there's nothing, you're not giving up any of them for just because you want something else. Yeah. So there's a company called RightScale. They publish a report called the State of the Cloud Report. They publish that every year. This company is essentially a cloud management company. It enables organizations to move into the cloud. It enables them to essentially take their traditional applications and go into the cloud. So they published this 2018 report. And according to them, one of the interesting aspects was that 81% of the organizations that were surveyed, and these are all organizations that have at least 1,000 employees. So 81% of these organizations, they are banking on what is known as the multi-cloud concept. So they're not banking on a single cloud. They have AWS and Azure probably, and even Google Compute, right? And another figure which is not here is about 51% of them, they're using hybrid clouds, meaning they have both public clouds as well as private clouds, right? So what are they running on these cloud platforms? They're running all sorts of applications. They're running multi-Linux applications, multi-OS, which is Windows and Linux, and of course, they're running multi-cloud. So Docker EE is the only platform that addresses all of these concerns. It does not matter what is the infrastructure layer. It can be private cloud, public cloud, or it can be bare metal as well. It can be even Raspberry Pi if you wanted to run it there. It runs on all popular versions of Linux, like CentOS, RHEL, Ubuntu, SUSE, Oracle Linux, and it also works on Windows Server. Matter of fact, Docker has been working with Microsoft to provide container technology support within Windows Server on par with Linux container technology. Another aspect I should tell you is that Microsoft has bundled Docker as part of its Microsoft Windows 10, Microsoft Windows 2016, and Microsoft Server 2018. This is phenomenal because it is unprecedented. Nowhere before has Microsoft bundled a third-party product in their operating system. Right? This is the first time it has done. So that is a testimony to the synergistic relationship Docker and Microsoft has been having. Okay. And what is more, you get interoperability and first-class support for the containers that are running across Windows and Linux platforms. Meaning you can actually have services communicating with each other on a common network. So you can do that using what is known as the Compost Pile. How many of you do not know what a Compost Pile is? Okay, there are just a few, just 3 people. So a Compost file is essentially a YAML file. This expresses all your services. You can say how your services should come up, what are the environment variables, what are the ports that needs to be published, and how do they communicate with other services. So you can have a single Compost file, and you can have services. And let's say you have a Linux service and a Windows service. You can put them on a common network. So that's how they're going to communicate. They can only communicate if they have a common network between them. And now, even though they are automatically scheduled on different operating systems, the Windows container goes on the Windows operating system and Linux goes on the Linux, they can communicate on a single network. Right? This was not possible before, because now you needed the Windows networking stack to talk to the Linux networking stack, which was a very, very big step ahead now. And also, it does not matter where you are on a journey. You could be a brownfield, totally brownfield organization. You could have a lot of monolith, lot of legacy applications. All you want to do is you want to just lift and shift your application. You do not want to refactor your code. You want to take these applications and you want to leverage the container technology, which is what we call as modernization. Because once you put it inside a container, now you can do whatever you want to do with it. You can put it in the cloud, you can do scaling, you can refactor, you can do whatever else later on. But the first step is to just get it into a container. So matter of fact, in Docker E, we bundle certain tools. There's one tool that we've been using quite often. It's called DAC, Docker Application Converter. So this has what are known as detectives. So you can run it on a VM, it goes and detects what is running in the VM, and it generates a Docker file from there. And then somebody can review the Docker file and make necessary changes. And once you build an image from here, you get a Docker image. So this is without doing any refactoring of the code. You don't even need to know what is inside your application. That's the first step for you to get it into a container world. But it can also be on the other end of the spectrum, where you are a totally greenfield organization, where you have a lot of these modern technologies, microservices, serverless, IoT, edge devices, and whatnot, and that's also totally fine. You do not have to wait for us. You can modernize at your own pace. You can pick what applications are important for you. You can prioritize those, be it the legacy ones or the new ones or somewhere in between. That's totally up to you. And that is the choice that you get. Additionally, you can also integrate the entire Docker infrastructure with your existing tools. If you have CI/CD, if you have VCS, if you have image scanning tools or code scanning tools, those all can be integrated without you having to change your processes or your tools. Another aspect which I think a lot of you would love is that you have the option of using Swarm or Kubernetes orchestrators at the same time within the same cluster. When you install the cluster, you do not have to make a choice. You do not have to say, I need Swarm or Kubernetes. Both are available, both are equal. You can make the choice later when you actually deploy your application. And once you deploy your application, even then you can make a choice to choose the other orchestrator, which means you can run Swarm on day 1 on your application, and for whatever reason you want to change, on day 2 you can change your application into a Kubernetes application, all using the same cluster. You do not have to be stuck doing the same thing in the same way. So you can pick and choose whatever you want to choose. As I was saying, today it's Swarm and Kubernetes. Tomorrow it could be another orchestrator if there is one, and that's totally up to you. You can use whatever you want to do. Every single worker node is compatible. Every single worker node in the cluster is compatible with both Kubernetes and Swarm. Both would have the Swarm and the Kubernetes API enabled. So if you want to automate anything, that would be just possible, just absolutely easy to do. So we talked about the Compost Pile. So there are many organizations who have invested in this Compost Pile. They have a lot of Compost Files that are lying around because they were using the older Swarm mode of deploying applications. Now, that is another choice. You can use the existing Compost Files to deploy a Kubernetes application, and we do the conversion for you. So what we have done is we have built a CRD, which is a custom resource definition called as a stack, right? So we take the Compost file, and then we convert it into a Kubernetes stack using the CRD, and then you get your pods, your deployments, your services, and whatnot. But you don't have to do this Compose format. Compose is only if you like it. And matter of fact, there are many reasons for you to like it. I'll come to that. But if you want to do, if you have Kubernetes YAML, if you're into that, if you have a lot of Kubernetes YAML, or if you want to build it using Kubernetes YAML, that is also totally fine. You don't have to do it one way or the other. You can pick what you want to do, right? Now I'm coming back to the Docker Compose. I don't think Kubernetes has a similar concept of an application stack. Everything is an individual service. There's nothing that binds them all together. I think Compose does a very good job of saying that this is one application stack. This has, let's say, a web server, app server, database, or whatnot. As opposed to in the Kubernetes world, it'll be all individual YAMLs, and you can mash them together and say this is one application, but they're still separate, right? The other aspect is Docker Compose is expected to be extremely intuitive. It is something that you can hand type. Kubernetes, and I apologize if there are Kubernetes YAML experts here, Kubernetes is not meant to be handwritten because it's very verbose. There are lots of things that can go wrong, some indentation and all that. But Compose is extremely straightforward, and it's something that anybody can just write. Okay? So you have the best of both worlds. You get the ease of use, and you can still deploy a Kubernetes application using that. Okay? The only one aspect is that you cannot get Windows. At least today, Kubernetes does not have Windows support. So you would want to use only the Linux side of the pods or whatever. So how do you deploy Kubernetes? Again, choice. If you're a CLI junkie like me, how many of you are CLI favorites? Most of you. That's what I expected. Yes, great. But that's totally fine. I mean, if you love CLI, or the people who attended this talk love CLI, you love it. Open up a terminal and you just bring up kubectl and you can do everything you can using kubectl. But if you're not like the most of us, if you like to use the graphical interface, UCP has all these buttons and text fields and validations and all that. You can just use that, and you can upload a YAML file, which can be whatever in GitHub or whatever, and then you can modify it directly from here. So the choice is yours. Be totally CLI or be in the graphical interface. Right? And again, there is no compromise on security. Regardless of what you do, you are still bound by the same security constraints. You still need to authenticate to the cluster. You still have the authorization controls, which could be backed by Active Directory groups or LDAP or whatever you have. Okay? There's no compromise on that. I'll be showing a demo of that if I can. So again, the Kubernetes that we bundle along with Docker E is the vanilla upstream Kubernetes, which means that if Kubernetes supports it, you can do the same thing in here. If you're a hardcore techie and you love Kubernetes and you know all the edge cases that Kubernetes can be made to work better for you, so it's more power for you, you can do whatever Kubernetes does directly within Docker E, except now it is a supported platform, right? You want to bring up pods with multiple containers or single container, totally fine. You want to do controllers, you want to do replica sets, deployments, you want to do deploys, rolling deploys, stateful sets, daemon sets, batch jobs, cron jobs, totally up to you. You want to do some more advanced features like HPA, horizontal pod auto-scaling, blue-green deployments, ingress controllers, Helm charts. You want to set up a service mesh. Everything is available. Nothing is going to stop you because this is the vanilla upstream Kubernetes. Absolutely not modified. They say the Franken Kubernetes and all that, but there's nothing modified. This is the vanilla Kubernetes. Right? Yes? Yeah, this is a best practice. It's a general Kubernetes best practice. When you want to schedule pods, the pods need to have a life cycle. So you can use what are known as deployments. Deployments abstracts out the life cycle. So meaning if a pod goes down, the deployment will ensure that the pod comes back up. If you do it directly, the pod doesn't have any life cycle controls. If it goes down, it just stays down. And you can do all the rolling updates, deploy, scaling, and all that using deployments. So that's the aspect. Another aspect is the networking aspect in Kubernetes, but let me talk about the Swarm aspect. So in Swarm as well, we have the CNM, which is the container network model. We use overlay networks, which is based on VXLAN technology. There is a default CNM driver that comes with Swarm mode, but you still have the choice. You can go and get another CNM. There are many. They're from Cisco and Vive and whatnot, Cisco Contiv and Vive and all that. Similarly, on the Kubernetes side, we package and we bundle the Calico CNI driver. And again, this is just the default choice. You're not bound by it. You can rip out Calico and you can bring in another CNI driver and use that instead. Matter of fact, just last week I was at a customer who did not want CNI. He wanted to use Cisco ACI, and we did that. We did just that. But he had support from Cisco, and that's what he wanted for whatever purpose, and that's completely fine. So this is a concept that we call as batteries included but swappable, which essentially means that in Docker EE, we provide you the batteries or the tools and ammunition for you to run a complete enterprise setup. But if you so choose to rip out one or more of them and replace them with another tool of your choice, we make it completely easy and completely possible because everything is API driven. Everything is just plug and play. Right? So you get the best of both worlds. You get, again, Docker EE, all the other things, but you just want to change just one or two components, and that's totally fine. This slide I just added in the last minute. I just wanted to explain. This has nothing to do with Docker EE per se. This is just to show that Kubernetes and Docker Swarm are, for the most part, they're on par with each other. Both are pretty well battle tested. Although Kubernetes has had a longer rinsing period, so to say. For a majority of your application, it should not matter to you which orchestrator you use. It should work just fine. There's a minor set of applications, some special applications where you may want to consider this versus the other. For example, on the Kubernetes side, if you want auto scaling, that is something that you want to use Kubernetes. Or if you want to do batch jobs or cron jobs, maybe that's another option. On the Swarm side, if you want a very simplistic, very quick, if you don't want to really train, like pretty much 1 hour of understanding how Swarm works is enough for you to get up and running with Swarm, right? Another thing is Windows. At least today, not yet. Kubernetes does not yet have Windows support. Swarm today has, so that's another consideration. If you have Windows containers, you want to do Swarm. Matter of fact, I don't know if I mentioned, Docker is working with Microsoft to essentially to spearhead the Kubernetes support on Windows. So the idea is to contribute back the code to CNCF much before anybody else does, because we work directly with Microsoft. So Windows support is coming much sooner than anticipated. Okay, right now it's in beta. It's Kubernetes Windows support is in beta, right? But everything else you would have the same layer 7 routing, not the same, but you have comparable layer 7 and layer 4 routing. You have load balancing, service discovery, networking, everything else, volumes, all the same things you would have. They're pretty much equal. It's only for the minor applications that you need to consider the differences. Okay. And finally, I was involved in this particular case study. This is a case study that we did for a very large, one of the largest US financial firms. So they had about 500, this was just one phase of it. They had many other applications, but this was a phase where we picked 500 applications and they were running them on 5,300 VMs. Their total cost of ownership annually came to about $12 million. And then we modernized them and we extrapolated the cost savings. And the same 500 applications, we can run them on less than half of the VMs, on 1,320 VMs. We realized a savings of 90% of CPU. So 90% of the CPU was not being used. And that brought down the TCO cost by about 41% to $7 million, right? So this is the power of choice. This is what allows you. The choice allows you to actually see monetary gains, fiscal gains. Okay, and how are we doing on time? Do we think we can do a demo, or do we want to do questions? Demo? Okay, good. Okay, so what I have here is, if you can see, I built this in the morning, and it's very slow. It's been very slow. So this was the UCP that I wanted to show you, and I had purposefully not added one of the nodes. I wanted to show you. I don't know how many of you are familiar with the Swarm mode of adding nodes. It is extremely simple, extremely straightforward. You run Docker Swarm join token, and then it gives you a snippet. You take the snippet and you run it on all the servers, and you have a cluster. It literally takes you seconds. Now, the same concept, we have extended that in the Kubernetes world, right? So when I do the same, right now I have 5 nodes, and I was going to add, is it clear? It's not clear to me, but anyway. I was going to click on add node, and I'm going to copy this particular text, and I'm going to log into another one of these servers that I had not loaded. Increase the font size, okay. And if I just paste it, it will, of course, it will add it as a Swarm cluster, but the same thing, it will add it as a Kubernetes node, right? So nothing different. For you, if you already knew Swarm mode, nothing for you to do. It was all set up, and now when I come back here, I should see the new node, the 6th node, come up. Okay, so it's coming up. So that's the red. And it's coming up as a Kubernetes node because I chose it to be Kubernetes. There's a setting that I can say all the new nodes that come up, that join, should be Kubernetes or Swarm or mixed, right? If it is mixed, then it doesn't matter. You can run Swarm application or Swarm containers or Kubernetes pods. It doesn't really matter. But generally, it's not recommended because now you have too much of things going on the same node. Generally, for production workloads, we recommend either run it as Swarm or Kubernetes. But so that's one thing that I want to show you. The other thing I want to show you is the CLI aspect of it. The client model or the authentication and authorization aspect of it. Right now, I'm logged in as an admin. Admin has full privileges, but assume I could have been any other user, right, of a special privilege. Like I can do some things, I can do some other things. So when you log in as that particular user, you can generate what is known as a client bundle, right? The client bundle is nothing but a set of certificates that authenticates you into the cluster, right? It also has your authorization controls encoded into it. So once I get the client bundle, I can unzip that, and that gets unzipped here. And now I'm going to use that. So this is done. CD UCP, and then that was /2. I already had /1. And if you look at this, this is just a set of certificates, and then there are some utility scripts. There's the env cmd for the older Windows systems, env ps1, which is the PowerShell, and then env.sh. Mine is the MacBook, so all I need to do is just source that file. That's it. Now I am authenticated and authorized into the cluster based on what was my login, because it was generated using my login. So it set up my context, it set up my UCP controls and everything. So now if I do a docker node ls, I should be able to see those 6 nodes, right? So these are the 6 nodes, and I have one of them which is the leader, one of the manager. But I can also do kubectl get node, and that'll still show me the same thing, except it shows it from a Kubernetes perspective, right? So you don't have to choose. All the nodes are Kubernetes enabled and Swarm enabled. And now just Kubernetes works, kubectl works. I can do anything using kubectl. I can do a kubectl, create a deployment and whatnot and everything. So let me see if I can get a simple application running. So that was, so now I can do all the kubectl commands directly from my command line, but I'll choose to do something from the interface. So I have a very simple application that I built. It's not a great application, but it serves the purpose. This is Compost. This is the Compost file. So some people did not know what a Compost file was. This is how it looks. It's just a version and some services. It's a very typical 3-tier web app database, right? The web is a caddy web server. Application is some code that I've written. It's a hit counter demo. Every time I refresh the page, it just increments the count depending on which container it hits. And database is where the counts are maintained so that next time when I come, it can increment it. So I'm going to just take this, and I'm going to go here. Recall the aspect that I told you that we have created a CRD called a stack. So now there are these shared resources. So this was the dashboard, by the way. I don't know if I talked about this. But this was the UCP dashboard where you can see all the health of the system and all in general. It's not meant as a monitoring stuff. It's just a dashboard to show how your cluster is doing, how many nodes are there. If there are any errors, it would show as red, and how many nodes are up or down, how many managers. And here, I am going to click on the shared resource. I'm going to click on stacks. And then I'm going to click on create stack. I'll give it a name, cconf probably. And here, this is where I can choose. At deployment time, I can choose what I want to do. Do I want it to be a swarm services? Do I want it to be just basic containers? Or do I want Kubernetes? And just because we are talking about Kubernetes, let's select Kubernetes. I can also say what namespace I want this to be in. We'll choose demo. Oh, no, I'll choose container.conf. I created it earlier. And I'm just going to paste that right here. Right? And once I create, what this would do is Docker EE would take my compose, parse through it, and convert them into Kubernetes resources because I selected Kubernetes. Had I selected Swarm services, it would have just done a similar Swarm services, network, volume, and whatnot. Right? I think it needs to pull the image and all that, so it will take a few minutes. But essentially, the application should be up. And we can also look at it from the command line. So I put it there. So if I go to the command line, and I do kubectl get stack, oh, I need to do namespace because it was container. This will not show any, I guess. Okay. So this should show our what demo or something, whatever I gave. Name. cconf. That's the name I gave, I guess. So I can also do the same thing. Let's look at this. kubectl edit stack cconf -n. I'm thinking people are familiar with the syntax, right? kubectl get, kubectl edit. So I'm essentially editing the resource, the stack resource. And because I put it in the container conf namespace, I'm passing the -n container conf. And if I do this, I should be able to edit the stack directly from the command line. As a matter of fact, I think I did not publish any ports. So this was the Compost file that you saw, right? The same thing, the web app and stuff. I did not publish any ports, meaning I cannot hit it. So I'm going to publish the port, the web server port, which runs on 2015 on some high port. I'll just select whatever 34,000. Right? And I'm going to just save this, and hopefully the application should be up on that port. Let's see if this comes up. It should. I just need to refresh, and I'll just use the same thing. 34,000, and there you go. So that's so I can do. I'm just refreshing the page. So every time it hits a container, the counter gets incremented and it goes to the database, to a Redis database. And and there's a WebSocket and all that sort of additional stuff. But that's essentially using a Compose application and bring it into the Kubernetes world. So you can migrate at your own pace. You can migrate slowly, as and when you are familiar with Kubernetes. You do not need to be a Kubernetes expert on day one. Okay. So, and then the last one I want to show was DTR. This is the Docker Trusted Registry. This is where you put all your images. I put an image here. I was trying to do scanning, but I could not download the CV database, which is like 160 MB. I could not download it here. But essentially, you can look at the images. You can look at all the layers. Here is where it says scan failed. It's very light. But essentially, I can enable the scan directly here. If the CV database had been downloaded, I could have just clicked on it. And then what it would do is a Docker Trusted Registry would essentially go layer by layer and look at all the binaries inside each layer and compares the hash of it to a known to a CV hash. And if it matches, then it knows that there's a vulnerability in that, and that would have been triggered as whatever vulnerability is it. And then you can take action on it. Or you can hide it saying, I'm OK, I just waived this. It's an exception or whatever. And there are many other features like webhooks and all that, but that's essentially the Docker Trusted Registry. Okay. So that's what I wanted to show you. Any questions?
Docker Compose, I have used a version 2.1. It contains a IPv6. If I see latest versions of 2.3 and all, we don't have the IPv6.
Correct.
So if I want to migrate it to Kubernetes or Docker Swarm, is there any problem will be there? Because I need to have a customer requirement for IPv6.
Right, right.
So if I want to, is there any way I can upgrade?
So you're talking about I think what you're talking about is the older Compose, which was containers only, and the newer Compose, which was 3.0 and upwards probably, which is using Swarm mode. Am I correct?
Yeah, yes, not only that, my question is enabling the IPv6. That is available in the Docker 2.1 Compose.
And it's not available in the newer versions?
Yes, I heard that.
Okay. I'm not aware of that. I thought it should be available, but if it is not, then I can follow up on that. I assumed it is. I mean, that would be a break of functionality if IPv6 was available in an older version and not in a new version. I need to understand what is going on out there.
Suppose if I want to migrate it to latest versions, I cannot. And also if I use the Docker KO Compose to convert the Docker Compose to Kubernetes, there is a one open source software, KO Compose.
Oh yeah, no, Compose, yeah, K Compose.
That is not working for me because due to this issue.
Okay, have you tried it okay, I don't know. You can try a Docker E trial and put it in there. So the Compose to Kubernetes translation is only in Docker E.
Okay.
Okay. So what I would suggest, and I can work with you later on if you want, is get the trial version of Docker E and try to do the same thing as what I did. Paste your Compost file in the stack and see and select the Kubernetes service and see what happens.
Okay.
Okay, because if it does not, then that's an issue, and that's something that we would have to solve.
This is available in only EE.
Correct. This is
it is not available in CE.
This is not available in CE. This is only in E. Correct.
Okay.
Correct. That's one of the differentiators. Any other questions? Yes.
Nice presentation. This FreeBSD OS support, any plan is there, or it is like
previously OS support
for Docker? It's, in the list it was Windows, Linux was there. FreeBSD was not there.
Oh, what do you mean? Previously it was not there.
Yeah, FreeBSD Docker support is not there, right?
Oh yeah, Windows is kind of new, but not so new also. It's been there for almost 2 years now.
No, Windows I'm not telling about, FreeBSD OS.
Oh, FreeBSD, oh sorry,
Yes.
Okay. FreeBSD is probably not there.
Is
But
there any plan?
it's not there for the Docker engine, but you can definitely run the Docker client on that if that's what you want to do. But FreeBSD, no.
Okay, so in FreeBSD we cannot deploy any containers, you mean?
No,
just
but
the
you could
client?
try, I mean, it should work. It's just that it's not supported.
Okay.
It's not supported. You would not get support from us. Because the thing is, there's a finite set of applications, finite set of platforms that we test against. We have like about 10,000 tests that we run. We have identified these are the enterprise platforms. FreeBSD, unfortunately, is not one of them at this point in time. So we can't stand by supporting it.
My other question is that Docker, currently Docker EE, you are telling supporting Swarm orchestration and the Kubernetes orchestration.
Correct.
So this support down the line, it will be for always, or it is like that will be Swarm support will be discontinued?
Nothing like that. That's one of the things that I wanted to clarify. I've been speaking with some of the people here, I've heard that people are concerned that we are moving completely into Kubernetes. Somebody used the word that we are pivoting to Kubernetes, which is great. I have nothing. I mean, Kubernetes is a great thing. I mean, it's a fantastic, robust thing. But we love both. It's the best of both worlds, right? Swarm is great from a simplistic perspective. Probably does not have all the features of Kubernetes, right? So we have a lot of customers that are running on Swarm mode. Matter of fact, Visa.com is running on Swarm mode.
To Twitter, I think.
Twitter, no, I don't know about Twitter. I don't think Twitter is running on Swarm. I don't think so. Or maybe they're doing open source, they just don't tell us. But Visa.com is one of them that I personally support. They're close to my house in Virginia. So there is nowhere soon are we giving up support for Swarm. We are enhancing it, we are maintaining it, we are addressing all the bugs, but we're also doing Kubernetes, right? So you can rest assured that we will support it. There's nothing in the near future that we are abandoning it.
Thank you. My last question will be that in the runtime, actually, there are many runtimes. Docker is now one runtime actually. So in that line, you want to tell something?
Yeah, that's a good thing. I did not mention that. So I keep talking about choice, and I keep saying batteries included, but swappable, which is all the way down to the stack, including the runtime, including Docker itself. You're talking about Docker itself, right? So you can, yeah, if you want, if it works for you, swap out Docker and put something else in its place. And that's totally fine. If it works for you, that's great. I've heard Rocket is there, and there's this containerd and whatnot. And yeah, that's something that if you want to do. There was one of the hackathons that I was involved in like last year, and I tried to get Rocket working, and I just couldn't get it working. So I don't know if it's as mature. Honestly speaking, I'm not saying because I'm from Docker, but that's something that you can definitely do. It is a swappable model.
Okay, so it is our choice actually.
It's your choice, yes.
So now the point is that there is today only there was presentation about virtualized based container. Virtualized container, like a VM is acting as a runtime. Kata container.
Katakoda?
Kata container, have you heard of that? There is another which actually...
I'm not following at all.
Okay.
Huh?
Yeah,
okay, I'm not familiar with that.
Yeah,
I'm not familiar with that.
Fine.
Sorry. One more question then.
I have one question. Like, if we run one cluster, one is in Kubernetes, one is in Swarm, right?
Okay.
So can we run different services, and can we make it integration in between?
Yeah, you can, but you'll have to go through the host, right? You'll have to expose it out to the outside world, and then you can connect it. That's one way that you can do it.
Like hybrid kind of, I'm expecting.
Hybrid, so yeah, okay. There is a beta.docker.com. You can register for a beta. So we are working on a federation service. I don't think it addresses Swarm to Kubernetes, but it addresses multiple Kubernetes clusters, right? Swarm to Kubernetes, I don't think you can. There's no way they can communicate with each other at their layer, the orchestration layer. They cannot. You need to expose them outside and then have them communicate.
Because they both will have different CNIs.
It's totally different. Yeah, they will not be able to communicate. I don't think that's possible. At least not at this time.
So will you release this as an open source project?
Huh?
Like these features? Will you release it as an open source?
Yeah, but also, yeah, there needs to be some differentiation, right? So that we can make money, so that we can invest that money in building more cooler features. If we don't make money, then Docker would just die.
Thank you.
I have a question here.
Where?
Here.
Oh, sorry.
So, scanning the public repositories. So, we are doing some POC and we download some Hello World. It contains some vulnerabilities, so it may contain viruses.
Correct.
Are you scanning those also?
Yes, we are doing a lot of scans. We are using. So there's a lot of problems because it's an open thing. Anybody can upload any images, right? The problems are not only in images, even the comments that they're putting. They put a link there, and you click on a link, and it installs a virus. So we are trying to address everything as much as we can. The images themselves, it's kind of hard to regulate them because sometimes images can have malicious code inside them. Not because somebody wanted to put it, just because they have malicious code doesn't make it malicious. It needs to be activated and enabled, or somebody needs to be using it. But still, we take the stance that, okay, it has malicious code, it needs to be fixed. We send them a cease and desist letter. We also use machine learning to understand what type of patterns there are, if there are people who are putting bit miners and all that into the things. So we're doing a lot of stuff to essentially to clean up the entire hub, to clean all the images.
So
we have an entire team behind it.
How frequently are you scanning those public repositories?
We scan it every day, every single day, once every day. Yes. There's a huge number of images.
I have a question. It's a great presentation. Thank you. I have a question. So you said that Docker Swarm and Kubernetes both are supported in the same cluster.
Correct.
So that's kind of very interesting, and for a newbie at least. Does it mean that every node has control component of both of these things?
Absolutely, yes.
So, okay, I have a question, sub-question for it. So, if we look at Kubernetes master node, control components, control plane components, the size itself is around, I don't know, it's half a GB or something like that.
Correct.
So, so
yeah, that's...
And then claiming that if we come up with new solution later on, and and Docker E can support even that. So that's kind of control plane component itself will grow to larger.
It can, yes, and absolutely, that's totally a valid thing. And matter of fact, one of the settings which we recommend that should be that should be enabled is to ensure that the control plane components run only the control plane components, and you do not want to run any application components on that, right? There are many reasons. One of the reasons is what you mentioned. There's a lot of I/O, there's a lot of memory, CPU utilization, whatever. That's one thing. The other thing is the security plane. This is a higher sensitive security plane, this control plane. If like you have your etcd database and all that, if some container or somebody can compromise that, then your entire cluster is compromised, right? So it is true. It is a matter of fact. I should tell you, I've always run, before Docker E 2.0, I would run everything on AWS micronodes, and I was perfectly fine. Today, I cannot run anything on micronodes because of the Kubernetes components. They're pretty heavy. I need to go to the medium or the large, whatever it is, the next thing.
So did Docker think of, making it as standard? For example, instead of having multiple service discovery components, like making it as a standard, and then making it interchangeably between Docker Swarm and Kubernetes in those terms. So,
well, actually, we do that. So when you set it up to be Swarm versus Kubernetes, we ensure the unnecessary containers on that particular node are stopped, are taken out, right? So there's a setting. It's just a radio thing. You can say this. You click on the node on the details. You can say this node is a Kubernetes node, and then we bring the Kubernetes, the DNS, kube proxy, and Calico node, and all the other container or pods. We bring it up on that node, but otherwise it's not running. So we are doing that pretty much right now.
thank you.
Yeah, sure. Thank you. All right. Thank you very much. Thank you for joining me.